So we have a project.
A big one.
Well, there's a lot of video cards in there. Oh, we're mixing the R's and the G's.
Yeah.
They don't like that.
As you can potentially tell by the difference in greens, as I observed recently.
So this system's kind of nuts. It's a system that's got DaVinci Resolve, but really we're exploring how multi-core, like many-core workstations scale. Because I've been working on that. There's been some news around that with like Threadripper, but it doesn't always work, and not every program is built to scale. But certainly not Premiere.
Definitely not Premiere.
But this video is not about Premiere. This video is about DaVinci Resolve, which is available on Linux and Windows. And
Mac.
And Mac. Well, Mac's, I mean, it's not a Mac that's got a lot of horsepower. So that's a little bit of a problem.
Yeah.
But we were thinking, like, it would benefit both of us if we could come up with something that wasn't insanely expensive, but that would make video production a little easier. And really, that's just offloading rendering to another computer, because when you're rendering, you can't do anything with your machine. Even with the 32-core Threadripper monster, it'll still like hitch and do weird stuff, and that's, I think, we figured out it's the GPU being really busy.
GPU driver just gets like totally locked down, and it'll get to the point that even your system cursor will just freeze, and your system isn't hung. Well, I mean, if the driver crashes, it is, but it just won't respond for a bit until it catches up.
So that's probably going to be a different video too, because we kind of got a fix for that if you're using the Red Giant plugins and Premiere and some other stuff. But again, Resolve. Resolve. What are we looking at with Resolve? We built systems that use 1080 Ti's and 2080 Ti's. This system has a 1080 Ti, a 2080 Ti, and two 1080s or something like that, something close to that.
Yeah.
Turns out that 850 watts is not enough for that configuration. The system turns off, but you can slave a second power supply. We're not going to get into that. This is just to show off and be like, look at this, look at all the craziness. This is a Threadripper 2970WX, 24 cores, 48 threads, 64 gigabytes of error correcting memory, NVMe and SATA storage, 10 gig Ethernet. And so this was our render server.
And this is especially useful if you're in a situation where you have multiple editors working at the same time, and especially if they have daily turnaround workloads where they're not just, you know, editing one project and they're done for the day, where they need to edit and then keep editing and keep editing, because you can have everybody just keep queuing projects up to this. It handles all the rendering and putting it in the final process, and your editor can just close project, open a new one, keep going, and multiple people can all load up on this at once, which is pretty cool.
Now, our primary test was DaVinci Resolve 15. And there's some differences between DaVinci Resolve 15 on Windows and Linux. One of them is around like activation and software licenses. So you have to pay for it, it's good software, all that kind of stuff. But in general, we recommend using the USB dongle because you can unplug it and plug it in somewhere else. If you use the codes, you can deactivate it on Windows,
right?
But not on Linux.
Yeah, and I hope they update this. I've made a couple complaints directly to people I've talked to about it, but you get 2 activations per key. If you have the dongle, it's only where it's plugged in. But if you use up your activations, on Windows, it's like, hey, you're out of activations. Let's close the other ones and start over. On Linux, it's just like, hey, you're out of activations, what do? And it doesn't give you any option to deactivate it. So if you're in the process of building a system and, you know, reinstalling your OS or the software a couple times, you'll want a dongle instead, just because you'll run out of licenses and not be able to redeem them anymore.
Yeah. But it actually worked really well. It worked shockingly well. It also didn't really scale all that well.
And part of that may be down to the project I built. I tried to load up like the beefiest codecs I could. So we're talking Blackmagic's own RAW codec, their Cinema DNG RAW recorded on my Ursa Mini Pro. We had some ProRes, lots of crunchy H.264, which Premiere struggles with a lot. I don't know what I was gonna call it. Resolve handles it really wonderfully. And then Blackmagic's own just uncompressed RGB, which is 1 gigabyte per second. And it still flew through that.
So I guess in order for people to generally understand, it's not really Resolve that is the bottleneck, or Resolve that has trouble with scaling. Architecturally, looking under the hood with Resolve, as you know, as I was working on this, Resolve is actually probably more well put together than Premiere. I mean, I don't think Resolve is at feature parity with Premiere,
right?
But in terms of like computer engineering and the computer science in Resolve, I think Resolve is a a much more compact, much more intelligently organized package. And where it could, it actually would scale really well. It would use all 24 cores in this Threadripper system, no problem. The problem is that it's modular, and so it gets software from a lot of other places. And near as I could tell, when certain modules would come in to do different things with different codecs or H.264 or whatever, it would affect how well it could scale. I mean, X.264, older versions of X.264 were just not designed for a lot of cores. It's not really true anymore, and Resolve seems to be on the bleeding edge of that.
Right.
But when you've got a mix of a whole bunch of footage, it has a little trouble. Now, we read on the internet that it works really well with 6K and 8K footage, things like red footage. We didn't test that. But
you're not shooting on reds, sorry.
Yeah, so. But fortunately, you don't have to buy a 2080 Ti or even a Threadripper 2990 to get the most out of it. It seems like the sweet spot is going to be something like a Threadripper 2950 and like a 1080 or maybe a 1080 Ti if you can get one of those on sale.
I do still recommend 64 gigs of RAM as a minimum, especially if you're doing 4K. It will eat it up and happily take as much as you can give it, but 64 if you're doing like a lot of high-end stuff, it's still my go-to. Now prioritize your actual editing machines to have 64 gigs over your render server, because your render server can go slower on 32 gigs and still benefit you, but 64 is the sweet spot right now of a minimum for 4K footage.
Now, in terms of particulars for the setup, it was actually pretty straightforward. We used Samba, which is like the file sharing thing that's compatible with Windows, and a 10 gig network. So a Quantia 10 gig NICs. This is the ASRock Fatality motherboard. It's got built-in 10 gig. Our other test system, I mean, we had what, 3 or 4 32 core Threadripper systems going at the same time, 128 gigs of memory in some of them, 64 gigs of memory in some of them. And using this as the render server actually worked really well, because the instance of Resolve that's running on this computer, it's all local, but Resolve has provisions in it where you can say this mapped network drive, like we used Z:. Z: on the Windows machine was mapped to that Samba share. And so in Resolve, you can configure that.
Yeah, and that's a huge advantage over Premiere workflows, on top of Premiere obviously not running on Linux, but if you are trying to map across multiple machines, those drive letters have to sync up and you get no alternatives. If it's not there, you have to relocate footage, whereas this gives you, even if you're just going Windows or Linux, you can have double like aliases for where the file shares are, which is really handy.
Now, we did try mixing GPUs. We did try having a Vega 64 in one of our Resolve workstations for an editor, and then GeForce cards in the render server. That did not work.
It can work in some specific situations, but if your target like master file is H.264 on Linux, Resolve only supports the NVIDIA NVENC encoders for H.264. And you don't even get the render option for that if you have a Vega card in your system, or if you don't have the NVIDIA drivers installed properly, as I discovered. And so you can't even send a render job to the system because it will say, hey, we don't have the codec we're expecting. And so you need some NVIDIA consistency there if H.264 is your preference. If you're going to Cineform or something else, you should be fine. Now, it's true that for the one particular project, it also didn't really scale well to multiple GPUs. It was what, like margin of error difference? Yeah, it was.
From one 2080 Ti, a $1,400 graphics card, moving up to 2. No real change.
And even from one 1080 Ti to two 2080 Ti's, it was like 10 seconds difference on a pretty long project.
Looking into that under the hood, the system was not super busy. So in terms of like, could multiple editors using the render server, you know, could your render server be able to scale to multiple people with multiple projects? And it looks like the answer to that is yes, but there may be some rough edges with the particulars of the software in order to support that properly. We didn't test this, but you can actually set up the render queue to run headless from the command prompt, so I'm wondering how multiple instances would run. There were a couple instances of that on the internet that I read about that was like, oh yeah, just run this and do that, because it was definitely not bogging down the entire system with a single project. The other recommendation was to split your project into multiple pieces and then render those separately. So if you've got a 20-minute composition, split it up into 2 10-minute compositions and render those separately in parallel on other machines. And then with DNX or Cineform, ProRes, well, you can't render ProRes on Linux, but with those kinds of codecs, you can just stitch them together without having to re-encode. So it can literally just pop them back together, and so it would speed things up. I guess my advice, if somebody is looking to embark on this, is to partner up with somebody that knows what they're doing. Or if you've got time, it's worth your time to do the experimentation, because if we figure out a workflow, I mean, even for our relatively pedestrian needs, if we just have a separate machine to run the renders on, and it's not a headache to be able to just hit a button and have that machine start rendering, that's actually transformational for our workflow.
Even if your actual like render server isn't as powerful as your editing machine, it can still benefit you, because the build I guess I might show off on my channel, I did the kind of low tier version of this. I had an AMD FX 9590, I had a 970 GTX graphics card, and then a 750 Ti. Super low end hardware compared to what we packed in here, and it was still rendering fairly quickly with the NVIDIA encoder, like not too far off from this, just not, you know, on par. But then my main machine was open up to keep editing, and so.
Yeah, this was not twice as fast, but maybe close to twice as fast.
Yeah.
Give or take. But
and
even
again,
not in the overkill config.
Right, yeah. And our needs aren't like, you know, again, we're not shooting on reds, we're not, there's other things you could do.
yeah, with a high resolution footage and that kind of thing. So overall, architecturally, I really have to give kudos to DaVinci Resolve. I mean, Adobe, they coming for you. It's not feature parity yet. I mean, there's some stars and asterisks and stuff like that there, but DaVinci Resolve is an incredibly impressive piece of software, and at least right now, it's more well put together than the labyrinthian mess of insanity that is Premiere, which we also worked on, and it's also going to be in another video.
Yeah.
So, and you're going to do a tutorial for setting this up, because there's like a PostgreSQL server and some other stuff like that.
Yeah, a lot of this on Windows is pretty much plug and play as long as you check all the boxes during installation, but on Linux there's a little bit of additional config that I will walk through, because you got to get it just right or you're going to tear your hair out, as I did for like the first 2 months of me trying to tackle this project.
And you'll be able to find that on your channel.
Yep, youtube.com/EposVox. Hopefully linked in the description.
Yeah, if I forget, somebody remind me. But yeah, DaVinci Resolve on Linux. Oh, I should have put this on the Linux channel. Oh well, that's fine. It's a little bit Windows and a little bit Linux. It's fine.
It's both.
Yeah, it really is both. But it's in our nice be quiet system where it's kind of being quiet.
Yeah.
Kind of loud too, because that 360 millimeter radiator on that 2970 CPU. Good Lord.
Gets pretty hot.
It is nice to be able to run the FFmpeg transcode jobs and stuff like that too. So you can package, you don't have to do stuff with Resolve. You can just remote into this thing and be like, hey, transcode this. And
yeah.
So you can do a lot more with it other than just run Resolve. So this has been a fun project.
And with a case this big, you could store a lot of files if you fill up all those drive bays. So that could be your whole file storage and your render server all at once if you needed to consolidate.
Yeah, you could run ZFS on Linux. You could, 6, 8, 10 hard drives off this motherboard, no problem.
This has been pretty fun.
Well, cool. Thanks for hanging out.
Yeah.
It's
Thanks
been
for
awesome.
letting me play with all the GPUs.
You can find more on the Level 1 forum, and hopefully we'll do the tutorial soon.
Yep.
And it should be good. See you there.